Welcome to Managing Azure Blob Storage. I'm Jeff Stillman, and I'll be your instructor for this course. A little about me. I'm a technical trainer and developer residing in Arizona in the United States. I have been a Microsoft certified trainer for the past 18 years, providing in-house development and training on Microsoft client and server operating systems, PowerShell, and Azure deployments. If you have any questions or should you need assistance, please send an email to support@cloudacademy.com. My goal is to teach you how to develop solutions that use blob storage in an Azure Storage account. This course is intended for developers that design and build cloud-based applications and services. It's also intended for those individuals studying for the Azure certification exam AZ-203. You'll need to have a basic understanding of Azure and have some experience developing scalable solutions, as well as being skilled in at least one cloud-supported programming language. Here's what will be covered in this course. Moving items in blob storage between storage accounts and between containers. Setting and retrieving properties and metadata. Implementing blob leasing. And finally, implementing data archiving and retention. By the end of this course, you will have learned how to move items in blob storage between storage accounts and between containers within a storage account. You'll also have learned how to set and retrieve blob storage properties and metadata using the Azure command line interface. Additionally, you will have learned about blob leasing and how to implement data archiving and retention. Once you have completed this course, we encourage you to rate it. Azure Storage Accounts are a cloud-based storage solution designed to meet all of an organization's storage needs, ranging from storing unmanaged virtual hard disks for Azure virtual machines to queues for asynchronous messaging between applications. Storage accounts are divided into 4 types: blobs, queues, tables, and files. Containers can be created with each type of storage as needed to further organize storage data. In this course, we'll be focusing on blob storage. Blob storage provides for the storage of 3 types of blobs: page, block, and append. Page blobs are a collection of 512-byte pages that are optimized for read and write operations. A common use for page blobs is for virtual hard disks used by Azure virtual machines. Block blobs are for the efficient storage of large blobs up to 4.75 terabytes. The blocks within a blob can be updated or deleted as needed. Append blobs are a form of blob storage that is optimized for appending operations. Modified append blobs write data blocks only to the end of the blob. Existing blocks cannot be deleted or updated. Now that you have a cursory understanding of Azure Storage Accounts and blob storage, it's time to create a storage account. In this demonstration, I'll show you the steps and common configuration options for creating an Azure Storage account using the Azure portal. From the Azure portal web interface, I'll click Create a Resource. From the new blade under the Azure Marketplace, I'll choose Storage and select Storage Account. In the Create Storage Account blade, I'll choose the appropriate subscription and the appropriate resource group. I'll select the development resource group. Now I need to give the storage account a name. This name becomes part of a URL that's accessible from the internet. Therefore, it must be a unique name and it cannot contain uppercase letters. I'll enter ccdev store account. And the green arrow indicates that it's a unique and acceptable storage account name. Now I'll select the location. For this one, I'll place it in the West US 2 location. I'll choose standard performance and I will select the storage v2 general purpose account. For replication, we have several choices: local, zone, geo-redundant, and read access. For this demonstration, I'll stick with locally redundant storage, and I'll set the access tier to hot for default. Then I'll click Next. If I want to allow secure transfers, I can choose to do so. I'll enable that. Do I want to allow access to all networks or selected ones? I'll leave that to all. Do I need to use a hierarchical namespace? In this case, I don't, so I'll leave it at that. And the next selection, I can provide a tag for this. I'll skip tagging for now, but this is an opportunity to be able to kind of organize resources other than by the resource group. So next, I'll review my selections and I'll choose Create. Now that the deployment of my storage account is complete, I can click to go to that resource. And now I've entered into my storage account. It's quite common for an organization to need multiple storage accounts, either for billing purposes or segregating development from production, or just to overcome the I/O storage limits of a single account. Creating multiple storage accounts is best done using a resource manager template file that can be downloaded from GitHub. As part of the ongoing management of blob storage, it may be necessary to copy or even move data between different containers within the same blob storage service. To facilitate the copying of data in Azure Storage, you can use the AZ Copy tool. The AZ Copy tool, a free download from the Microsoft website, is a command line tool for copying data in Azure Blob, table, or file storage between storage containers as well as between storage accounts. The current version of the tool, version 10, can be downloaded on any supported Windows, Linux, or Mac OS system. The moving of blobs between containers is not natively supported in Azure. So to effectively move blobs between containers, the blobs must be copied to the destination container and then deleted from the source container. This can be done from the Azure portal or using PowerShell's remove-Azure Storage Blob commandlet. It is possible to effectively move blobs between containers programmatically using the Microsoft Azure Storage Data Movement Library. This library contains methods that can be added to a C# project that can copy data between containers as well as delete the blobs after the copy process has completed. To learn more about the Microsoft Azure Storage Data Movement Library, refer to this URL. As with moving blobs between storage containers in the same storage account, there is no native support for the actual movement of blobs between storage accounts. Instead, the same tool that is used to copy blobs between containers within the same storage account also supports copying items between storage accounts, that being the AZ Copy tool. In fact, to move items between storage accounts, the same AZ Copy command is used with the same parameters. The key difference is that the source and destination URLs will be different, as well as the source and destination keys. Blob containers and objects have a set of properties as shown here. These properties can be accessed using a variety of methods. Visually, the Azure portal can be used to display container properties by navigating to the Blob container and choosing properties from the settings blade. Object properties can be displayed simply by clicking on the object and inspecting the Overview tab. Programmatically, blob properties can be exposed using C#, using the Azure Storage Client for .NET. Retrieving blob properties or metadata is a two-step process. First, the object must be retrieved using the fetch attributes or fetch attributes async method. Then the properties or metadata can be read or set as needed. In this code snippet, the first order of business is to retrieve the connection string for the storage account, load the blob client, and the images container. Finally, the attributes are listed by calling the list attributes method. The list attributes method uses the fetch attributes method to retrieve the blob container properties, and the last two lines output the container name and last modified date in string format. Metadata on a container or blob can be set using the set metadata or set metadata async methods. Metadata exists as name-value pairs and can be added to a container or blob by calling the add method for the container or the blob. In this example, metadata on a container is cleared and then two name-value pairs are added. Remember to use the set metadata or set metadata async method to commit the metadata to the container. PowerShell can also be used to retrieve blob properties and metadata by using the Cloud Block Blob class from the Microsoft Windows Azure Storage Blob namespace. In this demonstration, I'll use PowerShell to retrieve and set blob properties and metadata. To work with blob properties and metadata in PowerShell, we first need to set the storage context to the desired storage account and provide the access key. I passed the access key into a variable called sec. Now I'm calling the new Azure Storage Context commandlet, passing in the name of my storage account and passing in the variable containing the storage account key. The next thing we need to do is to retrieve the desired blob using the get Azure Storage Blob commandlet, passing in our context, the target container, and the specific blob we wish to read the metadata on. The native object type for retrieve blob is iCloud Blob, which is too generic to work with as is, so we'll convert it to a Cloud Block Blob and store the converted object in a new variable called Cloud Block Blob. Now we're ready to read some of the properties of the blob. Note that some properties are properties of the object, while others are technically properties of the properties. Some property values can be set. In this example, the content type is set to image/JPEG. The value is committed using the setProperties method. Initially, there is no metadata associated with a blob or container, but it can be set as needed. In this example, I've added a key value pair of object type equals nebula and photographer equals Stillman, and committed the metadata using the set metadata method. Finally, reading the metadata is performed by using the metadata property of the Cloud Block Blob object. And we can see that my name value pairs have been set. As a final note, blob properties and metadata can also be accessed programmatically using the Azure Storage REST API. The specifics are beyond the scope of this course, but details on leveraging this method can be found at this URL. Access to blob storage at container or blob level is controlled by shared access keys and access policies. The files within a container can and frequently are accessed by multiple users or processes. So there may be times when you need to update a blob and want to ensure that no other user or process can modify or delete it while you're in the process of updating it. Blob leasing allows you to take ownership of that blob for a specified period of time, between 15 and 60 seconds, or it could be indefinite. During that time, the blob can still be read, but it cannot be modified or deleted until the lease expires or it is released. A blob can only have one active lease applied to it at a time. Once a lease has expired or been released, another user or process could then acquire a lease on that blob. Leases can be acquired and released. They can also be renewed again for the same period of time. Leases may also be broken, which ends the lease but prevents the blob from being leased again until the first lease has expired. Lastly, a lease can be changed, which simply allows the ID property of the lease to be changed. In this demonstration, I'll show you how to acquire and manage blob leases using the Cloud Shell. From the Azure portal, I've opened up Cloud Shell and selected PowerShell. Now I'll acquire a lease on the wizard.jpg blob by running the following command. And I'll press enter. PowerShell returns the ID for the lease, and by refreshing my storage account archived images container, I can see that the wizard blob has been leased. Refreshing the container again, I can see that now that 30 seconds have expired, that the lease has also expired. I'll renew the lease using the following command. And I'll press enter. Now, if I refresh my container, I can see that the lease has been renewed. Again, note that I cannot specify a lease duration. Renewing it, I can only renew it for the same duration as the original lease. Now I'll acquire a lease on the Veil JPEG blob, this time setting the lease duration to -1, making it an infinite lease. And again, PowerShell returns the lease ID. Refreshing my container, I can see that the veil has a lease on it. By clicking on here, I can see that I have the option to break the lease through the Azure portal. However, I'll release the lease again using the Azure command line interface. And press enter. The command completes, and refreshing the container, I see that the blob is available for a lease. Blob leases can also be managed programmatically using C#. The Cloud Block Blob class has these commonly used methods to manage blob leases. There are additional methods for managing blob leases. Consult the Microsoft Azure SDK for .NET at this URL. Blob leases can also be managed using the Azure Storage REST API. The specifics are beyond the scope of this course, but details on leveraging this method can be found at this URL. Azure Storage offers different storage tiers, allowing for the storage of blob objects cost-effectively. The offered tiers for Blob Storage Account include Premium, Hot, Cold, and Archive, while the General Purpose V2 Storage Account offers Hot, Cold, and Archive tiers. The Premium Storage tier is hosted on high-performance solid-state drives, optimized for low latency and high transactional rates, and is intended for frequently accessed data. This tier has the highest cost of the 4 tiers. The Hot Storage tier is optimized for storing frequently accessed data and is designed for actively read and modified data. It incurs a higher storage cost than the Cool or Archive tiers, but has the lowest access costs. The Cold tier has a lower storage cost than the Hot tier, but a higher access cost. This tier is designed for data that will remain in this tier for at least 30 days, such as short-term backups. The Archive tier has the lowest storage cost, but the highest access cost. This tier is intended for data that will remain in this tier for at least 180 days and can tolerate several hours of retrieval latency. Data in this tier is offline and cannot be copied, overwritten, or modified, and snapshots cannot be taken of a blob in this tier. Blob metadata does remain available, allowing for the retrieval of blob properties, metadatas, and lists. To access the data in the Archive tier, the blob must be rehydrated. This is done by changing the tier for the blob to either cold or hot. Note that it can take up to 15 hours to complete the rehydration process. Storage tiers can be used as part of an archiving policy for blobs, moving less frequently accessed blobs to progressively lower cost storage tiers. Changing the storage tier for blobs can be done from the Azure portal at blob level by accessing the properties of the blob and choosing the desired tier from the drop-down list. PowerShell can be used to change the storage tier for a single blob or for all blobs in a container by using the Get Azure Storage Blob commandlet. By passing the objects to the Where Object filter, you can filter the blobs against any of the blob properties, most notably the last modified property. In this demonstration, I'll show you how to change the storage tier for blobs using PowerShell. First, I need to provide the storage context to the new Azure Storage Context commandlet, consisting of the storage account, which I'll pass into a variable called stgacc, and the storage account key, which I'll pass into its own variable. I'll also pass in the container I wish to work with into its own variable. Now I'm ready to execute the new Azure Storage Context commandlet. I'll pass in my storage account name and the storage account key, and then I'll store the results into a variable, CTX. So I'll execute that much of it. Now I'm ready to retrieve the blobs that I wish to work with. I'll call the getAZStorageBlob commandlet, pass in the container and the context, and I'll store those blobs in a variable so that I can work with them in the next command. Now I'm ready to change the tier for the blob. I call the iCloudBlob method for the blobs, and I call the property setStandardBlob tier, and I'm setting it to 2, which is the cold tier. And I'll go ahead and execute that. Switching to the Azure portal and navigating to the archived images container, I can see that my access tier has indeed changed. It was originally set to hot, and it is now set to cool. Lifecycle management is another Azure Storage Account feature that can be used for implementing a retention and archive policy. This tool allows you to create rule-based policies for general purpose V2 and Blob storage accounts to transition data to appropriate storage tiers and expire data at the end of its lifecycle. Lifecycle management policies can be managed using PowerShell, the Azure command line interface, REST APIs, or programming client tools in .NET, Python, Node.js, and Ruby. A policy consists of a version and a collection of rules. Each rule consists of a filter set and an action set. The filter set limits the rule actions to a filtered set of objects in a container or to a specific object name. The action set defines the storage tier or the delete action for the objects defined in the filtered set. Lifecycle management can automate the task of placing objects in the appropriate storage tier, allowing, for example, for data that hasn't been accessed in the last 30 days to be moved to the cool tier, and data that hasn't been accessed for 180 days to be moved to the archive tier. Immutable storage policies for Azure Blobs is an Azure storage setting that provides for 2 types of retention policies: time-based retention and legal holds. These 2 policies can be used for regulatory compliance, to secure document retention, and ensure that documents that are critical in litigation or criminal investigations are retained in a tamper-proof state. A legal hold policy places existing blobs in the container in a non-writable, non-deletable state until the legal hold is cleared, but blobs can be created and read. Legal holds are associated with a user-defined tag that is used as an identifier string. Time-based retention policies place the blobs in a container in a non-writable, non-deletable state for a specified interval. Time-based retention policies must be locked for the blob to be in an immutable state in order to be SEC compliant. Policies should be locked within 24 hours. Immutable storage is easy to configure. Simply navigate to the storage container and from the settings blade choose Access Policy. Select Add Policy from the Immutable Blob Storage section and select the type of policy, time-based or legal hold. In this course, you learned how to move blobs between storage containers in a storage account and between different storage accounts using the AZ copy tool. You also learned that this can be done programmatically using the Microsoft Azure Storage Data Movement Library, a set of .NET Core classes. You also learned how to set and retrieve blob storage properties and metadata using the Azure command line interface, and that this can also be managed in C#.NET using the Microsoft Azure Storage Data Movement Library and using the REST API. You also learned about blob leasing and how to manage blob leases using PowerShell. Finally, you learned about data archiving and retention using storage tiers, lifecycle management, and the immutable storage setting for blob storage containers.